Alrighty, boys and girls, welcome back. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. On this beautiful sunny Thursday, we're doing our countdown to SOL, and we are 25 days away, which that means it's crunch time, and you should be throwing up your fours because we're in the fourth quarter. But to do some quick math, I suggest you try these out. Again, anytime you see parentheses, that means multiply, So what I suggest you do is try this out, try this out on your own, and see if we get the correct answers. Alright, so hopefully you actually tried it out and pushed that boulder. So for that first one, quick math, we have 0.5 times 4 is 2, 2 times 3 is 6. 4 squared, again, this is 4 raised to the second power. It's not 4 times 2, but this is 4 times 4, which is 16. 4 times 7 is 28. And what I'm going to do is I'm going to say, let's have this be the row total. So let's add these three values together, and 6 plus 16 is 22. 22 plus 28 is 50. All right. So for other example, let's do 3.14 times 6, and let's try this again. 3.14 times 6 times 2, that's going to be 37.68. Again, multiply carefully. 4 times 3 is 12. And for this one, again, make sure you're doing the innermost first. And so we have to add 3 and 9 together to get 12. 12 times 4 is 48. Half of 48 is 24. Again, with the row total, I'm going to add these three together, and I'm going to get 73.68. And then finally, I'm going to have a column total, because I want to find these two added together. And so that's going to be equal to 123.68. If you are able to do this, you are able to do composite area, meaning I just found examples of these first four 2D shapes. So I have these first four and these other two 2D shapes. Again, a triangle, square, rectangle, circle, parallelogram, and trapezoid. So I was able to give examples for each of those and multiply them. So again, if you can do this, if you can do this, you can find or solve for area. All right, and just as a quick recap, what are some of those steps involving solving composite area? Well, again, composite means, and you can think about it as a compound word, it just means combine. All right, so first step, identify the shapes. We need to label the shapes, and we'll go through this example as well, but we'll have a little bit something different. And as you can kind of see at the bottom, a little bit of a spoiler, you'll see what we're doing here. So label the shapes, redraw the shapes, find the area of each shape, and then lastly find the sum. And when you're finding the sum, you're adding them together. So of all the shapes. All right. So those are our quick 5 steps to do this, and we'll do this each and every time. However, it says, what do we do if it asks for only the shaded area? And so I give you an example at the bottom here, and we're about to do that. But the only difference, meaning we have the same steps, but then we take the difference instead of the sum. So we take the difference. And when you see the word difference, you're thinking subtract. So let's scroll this up a little bit. All right. So in this first example, it says find the red shaded area. So what I'm going to do is I'm going to follow these steps. So let's actually, just kidding, scroll this back down. So it says identify the shapes. So what do we have here? Well, we have a circle in green, and we have a, well, do we know if it's a square or rectangle? We know for sure it's at least a rectangle for now. Possibly, I'll put it in parentheses, possibly a square, but we'll see. We can always check that. So now what do we have to do? All right, so that's step one, identifies. Let's label the shape. So I'm going to label, let me see if I can label here. Let's get a nice labeler in black for ourselves. So I'm going to have this circle. Let's let this circle be X. And let this circle be X and our rectangle be Y. So again, that's talking about that outside shape in there. So now it says to redraw the shapes. And so what I'm going to do is I'm going to have in green, let's see if I can find this here. Let's have in green our circle X. And in red, I have my rectangle Y. My rectangle Y. All right, so now that I redrew the shapes, make sure that you have any information that they give to you. So in the problem, it shows this segment from the middle to the side, which we know for sure is 2 inches. And specifically, we know that the radius is going to be 2 inches. That also means that the diameter is going to be 4, because the diameter is just the radius times 2, and so 2 times 2 is 4. So now what does that help us with on this rectangle? Well, maybe if I drew it a little bit perfectly, or a little bit better, it really does look like it has the same side lengths. But we can double check for ourselves as well. If you say that this amount, this radius is 2, that means that this entire length, this diameter, is 4. Let's try that again. Our radius is 2, our diameter is 4, and so if you think about it, well, what happens when we turn it? Meaning, is this length here also 4? Well, yeah, because it's the same diameter. And if we take that length and slide it to the right, that would mean that this entire length is also 4 inches. So that means that, yes, it is actually a square. And so we say that this square, Y, has a length and width that are equal as 4, and specifically 4 inches. So, step number 4, as we are using that number a lot, says find the area of each shape. So let's find the area of our circle, labeled X, and so I'm going to say A as the area of X, our circle. Again, using that wonderful formula sheet that you have in front of you, I will show here. Let's see if we can scroll this up a little bit. I know that the area of our circle is pi times r squared, meaning pi times r. So I'm going to have the pi times r to the second power, and we just plug in those values that we know. So we know that we use 3.14 times r squared, our radius squared. And so we have our area is going to be 2 squared is 4. 4 times 3.14 is going to be 12.56. Again, make sure you have those units in there as inches squared. All right, so now we find, again, the area of the other one, our rectangle or square, Y, which is going to be the area of Y, which is equal to the length times the width, And so we say, we plug in our values for our variables. So we have 4 times 4. That's going to be equal to 16, and that's inches squared. So now what? Usually we find the sum. However, we're not trying to find the sum. We're trying to find this red shaded area. So we're saying it's only this amount in here. So maybe I can draw some dashed lines to help show that. Again, it's talking about this combined area on the sides. Well, how would we find that? Well, very simply, it's the same steps that we just did, but we now take the difference. And so what I'm going to do is I'm going to say, all right, the area of our shape y minus our shape x is going to be equal to 16 minus 12.56, which is equal to 3.44 inches squared. And that makes sense as it's only talking about that little amount in the sides. Again, if you need to rewind, replay, slow down, closed caption, any of those, make sure you do. Or if you have a question, please do ask as I can physically right next to you. So on the back, I personally like this problem because, let's be honest, I'm a force of nature in that paint. And so I'm talking about this area in here. And so it's this part, as I drop the pen 14 times, it's talking about this area in here. So that let's do it right here. This part that is lined like that. That's the paint. I'm an all-star in the paint, and in some of the areas, or the only areas that teams can score on me is on this outside colored shaded area. What is the amount of area that is not shaded? Meaning, which ones is now shaded blue? I only do this to make it a little bit simpler or easier to see. So, again, our first step is to identify the shapes. And so what shapes are we going to need to use here? Well, we have rectangles. We got some rectangles. And we got some circle, or got a circle, I should say. And so, well, let's see. I'm only talking about that amount in there. So if I need to find the area on the outside, that would be a different problem. But for here, again, we're only looking for that inside amount. So for us, let's label now our shapes. And so let's say that this shape, this smaller shaded area in blue is going to be Z. I'm just using letters to help split it apart and help us find our answer. And let's say this circle, let's actually do this semicircle, because I only need to find this amount in, because that's what I'm going to be taking out. So let's say this semicircle is Y. So I'm going to say this is going to be Z, and this is going to be Y. And so now let's redraw the shapes. And so I have a rectangle, not drawn the scale, of course, but this is Z. And we have our circle Y. Again, we said that we only need half of that, so we'll divide it by 2 in just a moment. All right, so now, again, we redrew the shapes. We need to make sure that we have those, as we redraw them, you have to make sure you have the correct labels for them. And so let's find the side lengths of these. So we have 12 feet is going to be one of these side lengths. So we could say the side length is going to be 12. And then the other side length is going to be 15. All right. For the circle, now we have what? Well, does it have a radius? Not quite, but we do know that this amount is 12, and well, you guessed it, the whole way down that line, it also has that this is 12. So our diameter is 12, which makes our radius half of that, which is 6. Okay. Step number 4, make sure you find the area of each of those shapes. And so let's do actually, I'll keep it like this. I'll say the area of our shape Z. Oh, that's a pretty simple one. It's just length times width, which is plugging in our values for our variables. 12 times 15, which is, let's see, it should be about 180. And as always, make sure you have your units to the second power for area. So now I have my circle y, and so I'm going to find the area of that circle y, use the formula for circle, so we have pi times the radius to the second power, plug in your values for your variables, 3.14 times radius, which is 6, to the second power. Again, please make sure you are not multiplying by 2 because this is 6 times 6. So we have 6 times 6 is 36. Let's actually write 36 this time. There we go, 36. And let's do 36 times 3.14. Well, let's also make sure we calculate carefully. So let me bust out our trusty calculator car that we drive carefully. Hopefully, maybe. There it is. All right. So, as we have it here, let's do 3.14 times 36. That's going to be 113.04. Again, only using those first two decimal places, and make sure you label it as feet squared. All right. So normally, when you're talking about this entire shape, you're trying to find that area, you would add them together. However, since we are looking for just this amount in blue, again, we take the difference. So let's show it like this. We have the area of our shape Z, which is that small rectangle, minus the circle that we have here. But it's not that entire circle, right? We have to make sure that first we divide by 2. So it's going to be y over 2. So let's actually do that. Let's take this. Let's divide it by 2, and let's see what that equals. So we have, let's put it back up there, 113.04 divided by 2. Well, that's going to be 56.52. All right. So now that we have that, we can plug in our values for our variables to find the difference. So we have 180 minus 56.52. Subtracting carefully, what do you get? Well, we get 123.48, and as always, you have feet squared as your unit. That's the amount of area that I am a force of nature in on a basketball court. Again, make sure that you're circling your answer only, so that way you know where to look. As the last example approaches, make sure you can keep up with it. So again, if you have any questions, please do ask. So now, let me get this adjusted. All right, so it says the front portion of Shank's Tavern needs repainted. Well, actually, first it needs power wash, then we can repaint it. And we only repaint everything except for the front door. And so the door, let's actually label that. The door is going to be 1.5 meters, and it's going to be 2 meters wide. All you have to do is break it apart and find out how much paint we need. So we're not painting the door. So again, we're going to have our identifying our shapes. And so we have a triangle towards the top. We have a rectangle and another rectangle. So let's make it plural. All right. Label those shapes. So we'll say our door is, let's label that as D. Our front of the house is X, and the top of the house is Y. All right. So we have D and X, and we'll say the triangle is Y. We want to redraw those shapes, so let's redraw those shapes like so. We have Y. Well, what do we need for that? Well, we have the height of this. Well, it says it right there. The height from the top of the house to the start of the roof, that's going to be 1.2 meters. And the base of the roof, well, that's going to be the base of the house as well, so it's going to be 3.5 meters. Then we have the front side of our rectangle X. That's going to be the length times the width. We have the width as 3.5 and the length as 2.5. And lastly, very simply, the door, I'll do down here, the door, D, we already labeled that, but we want to make sure we do it here as well. So we have 2 meters and 1.5 meters. All right. Step 4, find the area of each of these. So we're going to find the area of y is going to be 1/2 times the base times the height. Plug in your values for your variables. So we have 0.5, our base is 3.5, and our height is 1.2. Multiplying carefully, you should end up with 2.1 meters squared. On the area for your rectangle X, again, it's just length times width. And so you have area of X is going to be equal to 2.5 times 3.5. Multiplying carefully, you should end up with 8.75 meters squared. And then lastly, I have the area of my door D, which is going to be also length times width. And so we have 1.5, use parentheses, times 2, which is just 3 meters squared. Okay. So again, to kind of reiterate what we're looking for, maybe let's highlight some of the stuff. So I'm going to highlight the amount of paint that we need. So I need to paint my roof. I need to paint the side of my house, but I don't need to paint the door, so I'm going to not highlight that. So I'm looking for the area of these two. So that means, let me actually do it like this. Let's do it in purple. That way it's a little bit easier to see. So I have all this in here is what I am looking for. So I have the area of, let's do our front side X plus our roof Y, but we're going to subtract our door D. Using those three values, I have 8.75 plus 2.1, but I have minus 3 at the end. Calculating carefully, as always, we're going to have 7.85 meters squared. So again, that's the amount of paint that we need to use for that front side of the house on Shank's Tavern. As always, if you need to pause, ask questions, please do, as I'm right next to you. And be sure to slam that subscribe button.